I'm Ann Mutchler with Semiconductor Engineering. I'm here at the 60th DAC in San Francisco with Frank Schirrmeister of Arteris. Welcome, Frank.
Thanks for having me.
So, Frank, what are you seeing as far as general trends in the industry, and how is Arteris going to address some of these things?
Okay, good things come in three. So I think there are three mega trends here at Design Automation Conference where we fit in. First one is AI/ML. The second one is the notion of integration with chiplets. And the third one is kind of what I would call SoC integration. So let's dive in. AI/ML goes two directions. It goes into enabling AI/ML semiconductor. And as we all learned and see, it's a huge renaissance, great for the semiconductor industry. Well, there's so much data going back and forth on the chips, between the chips, between the chiplets, that we are in a very, very favorable position as a network on chip provider, moving that data around. Things like bit width of what do you support, 1024, 2048, those are very important, but also the pure integration. Somebody has their neural network accelerator and then brings together all the top level components, just like Jim Keller of Tenstorrent in a recent release said, they don't want to worry about how to connect these things up. They are proven technologies like ours, so they rely on us to do the integration while they focus on their differentiation.
So, this also makes me think about the open ecosystem that we hear about a lot. So, can you talk about what the industry needs to do to encourage that and participate, and what does that do for the end customer, the chip designer, really?
Absolutely. So if you jump off from AI on that ecosystem, the connection between the chips, so the UCIe, for example, one of the sessions I was involved in a little bit was the UCIe session with an introduction to the field. We did that on Monday morning because UCIe will come up everywhere. And it is very interesting to see how you have these different players. And one of the questions I posed during the session was, well, okay, are you guys actually bringing together Cadence, Synopsys, Alphawave, and the three other Phi developers I forget right now? And do you actually do something like PCIe plugfests, right? Which is hard to do at the chiplet level. The ecosystem is thinking about it. So that's bringing together the ecosystem. And that then goes back to, I mean, AI/ML, as that was a jumping board, is a great starting point because it's circular, right? So we enable AI/ML developments for semiconductor, but then we use AI/ML in EDA quite a bit. That's the other big topic on the flip side of it. Obviously, on our side, we're thinking about those things as well. How do you optimize the connectivity using AI/ML? And then going back to the ecosystem thread, as you now, as an IP provider, look at all these options, you figure out, do I license the RTL? Do I build a chiplet? And that goes to the second point I made at the beginning of bringing together the board integration that gets smaller. We're talking a lot about multi-chip modules in the past. Well, those become all now integrated chiplet-based designs. And then on the other end, you have the reticle size limit situation of chips where you need to co-design your different blocks and then integrate them within a package using chiplets. So again, for us, we're in a very favorable position. Lots of data being moved back and forth. And for us, we have a lot of partners there. So from an open ecosystem perspective, we clearly live in Switzerland. We play with everybody. So we will, for example, see a CHI-based protocol for coherency on the chip, but then we need to talk to the memory interface provider, the UCIe interface provider, to figure out, well, do we support special features like the memory tagging extensions, AMPAM, and so forth? So it becomes a very interesting ecosystem part very soon, and that's where our position is great because we are at the center of seeing all the data as they're moving back and forth.
So, this also means, and I'm thinking about the automotive ecosystem, that means a lot of OEMs that didn't traditionally talk to each other need to start communicating in a concept may be called synchronization. Can you talk a little bit about that?
Sure. I mean, we started that discussion in Detroit at the AutoSense conference where you moderated a panel. My knowledge and background about that actually came from a previous automotive electronic congress in Germany where one of the OEMs pointed out, well, I have all these different things coming to me. I'm an OEM. I now have to deal with a cell phone OEM because by the time me, the greedy user, is in the car, I want all my data synchronized and my car know via calendar where I'm actually going to go, things like that. And that extends to consumer applications like my family members. They may be more interested in other OEM aspects from the consumer perspective. Does my PlayStation or my mobile game device work and is integrated? So that synchronization between the different OEMs at that level will be a very interesting challenge going forward. And that's where standards are important, right? So you have, I mean, even this goes up to the software level, to the social networks, right? Where we just, last week, they announced threads. One of the differentiating features, they run on an open protocol, right? So in the plane, I'm already able to play with the person in 34A. So just imagine that being extended. I'm in the car, Dad, why can't I talk to this car over there to play my game because he's waving at me, right? Things like that for synchronization will be very challenging and interesting in the future. So that's the solutions ecosystem. And on our end, there are things like the processor ecosystems and the foundry ecosystems, right, that make the whole situation even more fun, right? Playing with RISC-V, playing with ARM, playing with x86. So you have those different ecosystems around those processor architectures.
Speaking of RISC-V, how do you see the industry really working to truly enable design for the engineer of RISC-V in a safe and low risk situation? Because there are a lot of concerns today. How do you see that?
It is a challenge, right? So you have the RISC-V team talk about these billions of RISC-V designs having been shipped. There's a lot of interaction going on between the different RISC-V providers. The ecosystem is very good. If you look at the ecosystem map of RISC-V at this point, they have that on their website. It's actually fascinating how high up that goes already into the stack. For the things we are mostly concerned about at the semiconductor level, at the IP integration level, you think about things like which protocols do they then speak, right? So we see a lot of people today within a cluster perhaps doing co-optimization. They may use like custom things, or TileLink is an option there. And some of the other processor vendors have their own protocols internally within the different processor classes. But then when you go to the integration level where you integrated it with the interfaces, other accelerators, people seem to be focusing a lot on CHI, AMBA-based connections there. So that's where it's becoming very interesting for us. And again, being in Switzerland, you have to really work with all the vendors out there.
All of that fits within the network on chip,
That's right. Well, so we need
the fabric.
the fabric. We need to connect to those guys, right? So we have to have the right protocols available, the right controllers. And the other interesting thing about the RISC-V integration is, and that's something which companies like Amperas have been pushing on quite a bit, is they say it's freedom to innovate, right? To go back to Spider-Man, with great freedom to innovate comes great responsibility to validate and verify, right? So I think that's something where we still have some work to do to really figure out that different RISC-V implementations work together, that you actually have, once you have extended, that you have the full verification and validation executed on that. So that'll be another set of interesting sub-challenges in the classic EDA domain, right? So things like portable stimulus, how do you bring it all together? How do you create the right tests to make sure that all of it works? And that's just functional. On top of it, you need to take into account security and safety as well, right? So you now need to then, on top of that, put things like, is it actually safe and secure? Can I get it certified by somebody to be ISO 262 compliant? So those are just very interesting validation challenges which keep us busy at least for the next 5 years. So we'll probably, hopefully, have all the solutions ready by DAC 65, right?
So, what is the most interesting thing you've seen so far at DAC?
So one of the things when I came in, first of all, I think DAC is back. You can quote me on that, leave that in. I was actually very happy to see yesterday really full exhibition rooms. The research tracks, the engineering tracks are very exciting. I was in part of the engineering tracks. And so I think DAC is back. What I found at the beginning a little bit off-putting was that I didn't make new friends, meaning it's all same gray hair people I have been coming together with for the last, this is my 25th DAC. So literally for 25 years, what gives me hope is a lot of use. So Patrick Gernewald from the DAC committee, he did an outstanding job. There was a young fellows program yesterday. There was all this row of posters out there with students from universities. There were like demos. There was this dancing robot which came out of a university project. They had university demos. It recognized my emotion and danced accordingly. Well, that's something I like. And then things like Zeke Wheeler. This is this young innovator. I saw him earlier this year at a user event, and I basically called up the organizers here. Hey, this is somebody you should have at DAC, and lucky it fits into his summer schedule between school as a 12-year-old talking about how he gets to the space station. So everybody's kind of talking about how do you get new talent in here. And I must say at the beginning, I was kind of a little bit hesitant, but then seeing the young fellow program, seeing uh, people like Zeke presenting, I'm hopeful that there's enough youth coming in helping us to build electronics for when I'm at one point retired and need all the electronic support I can get, you know.
Well, that's great to hear. Well, Frank, thank you so much for your time. It's been a pleasure.
Thanks for having me.